If you remember from Algebra 1, you learned how to solve systems of linear inequalities, or at least to graph linear inequalities. This time they're not just going to be linear, but it's the same concept. So first you're going to pretend it has an equal sign and just graph the function the way it is. And then you want to determine should it be a solid or a dashed line, the same way we determine should it be a closed or an open circle. And then you're going to test and shade points, or really the space that that point is in. So for the first one, we have y is less than 1/2 x plus 4. So we'd graph it as if it's at equals. So we would begin at 4 and count our slope of up 1 over 2. And we could go the same slope, just -1, -2. So down and left is the same as up and right. We know because of the symbol here does not have or equal to, we're going to use a dashed line. So technically each of those points is an open point, but we're not going to be overly worried about that since we have our dashed line that pretty much takes care of it. Then we want to figure out which side should I graph on, or which side should I shade. Now there's some tricks, certainly because it says less than, I'm going to choose below, but sometimes it's not as clear where below really is. In this case, it's not too bad, but let's just pick a point. How about 0, 0? It's not on the line. It's very clearly on one side of the line, and it would tell me if 0, 0 makes the inequality true, that's the space I should shade on. If it does not make it true, I should shade on the other side. So let's test 0, 0. So I want to know, is 0 less than, that's question mark, 1/2 times 0 plus 4. So is 0 less than 4? Yes, it is. So I should shade on the side that has 0, 0. So that's this side over here. So everything on this side is a solution. Okay. All right, for the next one we have y is greater than or equal to x squared. So x squared, you could go about graphing this a few ways, but for me it's pretty quick to just kind of do a table. So 0 squared is 0, 1 squared, 2 squared is 4, 3 squared is 9, which I believe is off the charts already. And if I go -1 and -2, I get the same numbers. Okay, so something like this, and it's solid because we see that or equal to symbol. Okay, now we need to figure out where to test. We can't test 0, 0 because that's part of the parabola, so just pick something else. How about 2, -1? Why not? It's just a random number. So test 2, -1. I just want to make sure it's not part of my curve. So let's see. Is -1 going to be greater than or equal to 2 squared? 2 squared is 4. Is -1 greater than or equal to 4? No. So that point was over here. I should not shade on that side. So I'm going to shade on the other side. And what I mean by side is kind of like the other section. So one section's on the outside, kind of like the below part, and the other section's inside that parabola. All right, next we have x squared plus y squared is less than 25. If you don't recognize this from geometry, you could graph this in Desmos as well, but this is actually the equation of a circle. So we like to think of that 25 as being 5 squared. So really that's x squared plus y squared equals radius squared. So that is going to be a circle with a radius of 5 centered at the origin. So that means I'm going to be at 5 up, 5 on the right, 5 down, and 5 on the left to draw my circle. And I'm not the best at doing this. They always look pretty weirdly warped. Oh, that's not terrible. All right, so I want to figure, should I shade inside the circle or on the outside of the circle? And actually that should have been dashed because it does not say or equal to. And worst case scenario, just go back and erase some of it because that might be the easier way, especially if you forget. Okay, so it's dashed. Now we're going to test some points. How about 0, 0? Why not? So let's test 0, 0. So is 0 squared plus 0 squared less than 25? Is 0 less than 25? Absolutely. So I can shade where we get 0. So inside the circle are my solutions. And then with the next one, this is linear. We see there's no exponents going on here. So we should get y by itself. That's probably the easiest way to do this. Certainly you could try to get intercepts, but you're going to get some fractions. All right, so that's going to be 2y is greater than or equal to negative x plus 5, divide by 2. So y is greater than or equal to negative 1/2 x plus 5 over 2. So 5 over 2 is going to be really 2.5, 2.5. And we want to go down 1, right 2. So down 1, right 2. Down 1, right 2, and so on. And then we could also go up and left. Okay. Solid line because we have the or equal to. And then we should just test. 0, 0 is available, so why not? So let's test 0, 0. Let's go back to the original. So is 0 plus 2 times 0 going to be greater than or equal to 5? So is 0 greater than or equal to 5? Absolutely not. So we should shade away on the other side. So that'll be the top. And again, you notice that y is greater than or equal to, so it should make sense that we're shading where the y values are going to be greater than or equal to this line. All right, so to make it a system, really we're just going to put 2 and see where they cross, or really where the shading overlaps. So again, we have this circle. We have a radius of 5. If I think of the 25 as 5 squared. And again, it's dashed. It's sort of looking circle-ish. I will not judge your circle if you don't judge mine. And then the next one we just graphed before. We said that this was going to be, actually, no, let's shade. So since it's less than, and we tried 0, 0, let's see, we said is 0 squared plus 0 squared less than 25. So that gives us 0 is less than 25. So for this one, we shade on the inside. Whoops, let's do a different color. How about yellow? Okay, so we'll shade on the inside there. Okay. All right. Then for the next one, we have, we have y was greater than or equal to, and that gave us negative 1/2 x plus 5 halves. We worked this one out just before. So 5 halves was 2.5, and we went down and right. Okay, and this was a solid line this time. And we said that we were shading above it. So when we go to shade, that's this space up here. So really what I want to make sure I am shading, or my solution here, is that overlap. So where it almost starts to look green. Okay. Where it's both blue and yellow. So really this space, this space in here is going to be my solution. Okay, it's that overlap. Okay. All right. So for the next one, we have linear inequalities. We just have more of them. We can graph as many as we want on here. So we have x plus 3y is less than or equal to 12. So let's make that say y equals, or y is less than. All right, so we subtract x, that's 3y is less than or equal to negative x plus 12, and divide by 3. So y is less than or equal to negative 1/3 x plus 4. So we would begin at 4, and then we would count down 1, right 3. Solid line because we have or equal to. And in order to graph this one, we could test a point. If we test, say, 0, 0, we're saying is 0 less than or equal to negative 1/3 times 0 plus 4. So is 0 less than or equal to 4? Yes, that is true. So we should shade by 0, 0. Okay. For the next one, we have, we have that x plus y is less than or equal to 8. So when we subtract, that's y is less than or equal to negative negative x plus 8. So let's see, 8's close enough. Down 1, right 1. Okay. And that would be, again, a solid line. Okay. And then we're seeing, to test a point, how about 0, 0 again? Why not? So is 0 going to be less than or equal to negative 0 plus 8? Is 0 less than or equal to 8? Yes, that is true. So we should say shade on the 0 side. So that's going to be down this way. Okay. Then we have x is greater than or equal to 0, which is a vertical line. Really, that's just the axis. Or equal to, so it's solid. Greater than or equal to 0 is going to be to the right. And then lastly, we have y is greater than or equal to 0. So again, here is where y is greater than or equal to 0. And we're going to shade where it's greater. The numbers are definitely greater above it. So my solution is where all of this overlaps, and all of this appears to overlap in this section right here, this weird little quadrilateral.